The idle connection pool manager is a background subsystem responsible for lifecycle management of dormant database connections within a managed connection pool. It operates independently of request handling threads and periodically evaluates connection eligibility for closure based on configured idle thresholds and resource constraints. The system maintains internal state tracking for each connection, including last activity timestamp, cumulative idle duration, and connection health status. Configuration parameters for idle timeout behavior are specified in the connection pool configuration document. The max idle time parameter defines the maximum duration a connection may remain unused before becoming eligible for removal. Values are expressed in milliseconds and typically range from 500 to 30,000 milliseconds depending on workload characteristics. The default value is 5,000 milliseconds. The evaluation loop executes at fixed intervals defined by the scan interval ms configuration parameter. This interval determines how frequently the system examines each connection in the pool to assess idle duration. The scanning process is non-blocking and does not interrupt active connection operations. Scan intervals are decoupled from request handling to ensure predictable resource usage regardless of traffic patterns. When evaluating idle connections, the system compares the elapsed time since the last activity timestamp against the configured max idle time threshold. Connections exceeding this threshold transition to a pending closure state. The transition itself is asynchronous and occurs within the next evaluation cycle. No immediate socket closure occurs during this state change. Connections in pending closure state remain available for reactivation if a new request arrives before the grace period ms interval expires. This grace period provides a buffer against race conditions, where a request might be routed to a connection already marked for removal. After the grace period elapses without reactivation, the connection enters termination phase. The termination phase involves graceful socket closure and resource deallocation. Pending buffer cleanup operations are executed sequentially to ensure no resource leaks occur. The system maintains a closed connection count metric incremented upon successful termination. Failed closure attempts are logged but do not block subsequent operations in the evaluation cycle. Minimum pool size constraints are enforced during idle connection evaluation. The system will not terminate connections if doing so would reduce the pool below the configured min pool size threshold. This prevents resource starvation in scenarios where connection demand fluctuates. When minimum size is reached, idle connections are retained despite exceeding timeout intervals. Connection health validation occurs during idle evaluation. Each candidate connection is tested with a lightweight ping operation to verify underlying socket functionality. Failed pings immediately trigger termination regardless of idle duration. Successful pings update the last health check timestamp but do not reset the idle counter. The max close per cycle parameter limits the number of connections terminated in a single evaluation cycle. This prevents sudden resource release spikes and ensures gradual pool shrinkage during periods of reduced demand. When multiple connections are eligible for closure, selection follows a least recently used ordering to maximize utility of retained connections. Activity timestamp updates occur automatically whenever a connection is checked out from the pool for request handling. The update happens before the connection is handed to the requesting thread. Transactions that span multiple logical operations share a single connection instance and update the timestamp only upon initial acquisition. The adaptive idle time feature dynamically adjusts max idle time based on observed connection churn rates. When termination frequency exceeds specified thresholds, the system increases idle timeout to retain more connections. Conversely, low churn triggers timeout reduction to optimize memory usage. Adaptations are bounded by min idle time and max idle time hard limit parameters. Metrics collection during idle management includes connection count, idle count, pending closure count, and total closed lifetime. These metrics are aggregated at configurable intervals and stored in the metrics subsystem. Moving averages are computed to smooth transient fluctuations. Metrics are available through standard query interfaces for external monitoring systems. The idle manager shares connection state with the acquisition and release subsystems through atomic operations. State transitions are synchronized using compare and swap primitives to ensure consistency. No explicit locking occurs during idle evaluation, reducing contention with request handling paths. Concurrent modification safety is guaranteed for all visible state transitions. Connection reactivation occurs when a connection in pending closure state receives a checkout request before grace period expiration. The pending closure flag is cleared atomically and the connection returns to normal active state. The activity timestamp is not reset during reactivation, preserving accurate idle duration tracking for subsequent evaluation cycles. Shutdown procedures for the idle manager involve graceful termination of the background evaluation loop. In-flight evaluation cycles are allowed to complete before shutdown. All remaining connections in the pool are closed regardless of idle status. The manager signals completion through a shutdown complete flag upon full resource deallocation. Error handling during idle management prioritizes system stability over individual connection preservation. Exceptions during closure operations are caught and logged but do not interrupt the evaluation cycle. Failed health checks trigger immediate connection removal to prevent subsequent requests from encountering broken connections. The system continues normal operation following any individual connection error.